regression. The equation of regression of y on x is y minus y bar equal to byx times x minus x bar, where x bar is mean, that is sum of x divided by n, and y bar is also mean of y. Byx is the regression coefficient of y on x. It is given by byx is equal to r times sigma y divided by sigma x, where r is the coefficient of correlation. Or byx can also written as sum of x minus x bar into y minus y bar divided by sum of x minus x bar the whole square, that is sum of xy divided by sum of x square, where x is x minus mean, that is x minus x bar, and y is y minus y mean. Or byx can also written as, by interchanging x and y, we get the equation of regression of x on y as x minus x bar as bxy times y minus y bar. Bxy is the regression coefficient of x on y, given by bxy is equal to r times sigma x divided by sigma y. Or bxy is equal to sum of x minus x bar into y minus y bar divided by sum of y minus y bar the whole square, or sum of xy divided by sum of y square. Or we also can be written as bxy is equal to n sum of xy minus sum of x into sum of y divided by n times sum of y square minus sum of y the whole square. Note that r is equal to plus or minus square root of bxy into byx. Now we'll solve the first problem. For the given data below, obtain the two regression line, hence obtain correlation coefficient. X and y data are given. For these kinds of problem, first we should consider a table containing the requirements. That is, compute the sum of x and y from the given values of x and y. Sum of x is 70 here and sum of y is 150 here. Next, compute the mean of x, that is x bar, that is sum of x divided by n. 70 divided by 10 datas here, that's equal to 7. Similarly, y bar is equal to sum of y by n, that is 150 by 10, that is equal to 15. Next, consider capital X is equal to x minus x bar, that is x minus 7. Similarly, capital Y is equal to y minus y bar, that is y minus 15. Hence, I'll go to my original table that compute capital X, that is x minus 7, and similarly capital Y is y minus 15. 1 minus 7, that is minus 6. 3 minus 7, that is minus 4. Similarly 4 minus 7 is minus 3, and fill all the entries of capital X. Similarly, y value is 8 minus 15 minus 7, 6 minus 15 minus 9, 10 minus 15, that is minus 5, and so on. Next, compute the values of capital X square, that is minus 6 the square 36, minus 4 the square 16, minus 3 square 9, minus 5 square, and so on. And similarly, find capital Y square, that is minus 7 square 49, minus 9 square 18, 1, minus 5 square 25, and so on. Then find sum of capital X square, that is 204. Similarly, sum of capital Y square 8, 18. Then capital X into Y is minus 6 into minus 7 42, minus 4 into minus 9 36, and so on. And finally find the total, that is sum of capital X into capital Y, that is 360 here. Next, the line of regression of y on x is y minus y bar equal to byx times x minus x bar, where byx is sum of capital XY divided by sum of x square, that is 360 divided by 204. We got here 360 and 204. Fine. You will get 1.76 as the answer. Therefore, y minus 15 is y bar. The value of b by x is 1.76. Substitute. X minus x bar is x minus 7. Then y is equal to 1.76x minus 1.76 times 7 plus 15, or y is equal to 1.76x plus 2.68. The line of regression of x on y is x minus x bar equal to bxy times y minus y bar. bxy is equal to sum of xy divided by sum of capital Y square it is. That is sum of xy 360 divided by sum of y square is 818. It is sum of y square. You will get 0.44. Hence x minus 7 is equal to 0.44 times y minus 15. This implies x is equal to 0.44 times y minus 0.44 times 15 into plus 7, or x is equal to 0.44 y plus 0.4 you will get. The coefficient of correlation R is equal to plus or minus square root of bxy into byx, that is square root of 1.76 into 0.44. That is 1.76 positive sign and 0.44, that is 0.44 positive. Hence this is equal to 0.88. I will take positive sign. Since R is positive, both the regression coefficients are positive. I will show the regression coefficient bxy and byx. bxy is positive 0.44. Similarly, byx is also positive, that is 1.76. Hence R is positive. Thank you.